On April 16, 2025, these Super Hornets from Carrier Air Wing 7 screamed off the deck at 0230 local time. They had a simple mission. They were to deliver 16,000 pounds of precision-guided munitions to a Houthi-hardened facility buried beneath the hills outside Sana'a, Yemen. Taking it out would mean a big deal for stability in the region. American intelligence had pinpointed this facility as the command hub directing these strikes after thermal satellite imagery detected unusual heat signatures 30 feet below ground level. With F-18s soon inbound, what the Houthis thought was their impenetrable fortress was about to get an unwelcome surprise delivered at twice the speed of sound. At 0215 local time, two EA-18G Growlers took off on an important mission, and it is not what you think. In the early morning hours, these specialized electronic warfare aircraft took up positions along the Yemeni coastline to establish an invisible corridor through Houthi air defenses by using this device here, the next-generation jammer. Within seconds of activation, Houthi radar operators watching their screens saw nothing but electronic snow where clear air pictures had been moments before. Radar stations around Sana'a suddenly found their screens filled with ghost targets in all directions, as the jamming systems created phantom aircraft. Confused operators tried frantically to sort real returns from fake ones, while others attempted to switch frequencies. One desperate Houthi operator even turned on his acquisition radar at full power, exactly what the Growlers were waiting for. That is because of this pod mounted under each of the Growler's wings. This is the AN/ALQ-249 next-generation jammer, and it's what turned those Houthi radars into nothing more than expensive paperweights. Here's how. The next-gen jammer operates across the 2 to 18 GHz frequency range, which precisely matches the bands used by 93% of Houthi air defense radars. Each pod generates up to 8 megawatts of effective radiated power that it can send directly into an enemy radar and render it unable to differentiate what is white noise from real returns. These directed energy bursts are 10 times more powerful than its predecessor, which enables it to jam radars from 3 times the distance as before, to a whopping 660 kilometers, which is well outside the range of Houthi air defenses. Think of the jammer working like shouting so loud into a microphone that the speaker blows out completely. It's the same thing. After operating for just a few minutes, these Growlers created a 40-mile-wide electronic safe corridor through which strike aircraft can operate virtually invisible to enemy defenses. Meanwhile, the formation of Super Hornets approached from the southeast, flying over the Gulf of Aden before turning north towards Sana'a. As they crossed the Yemeni coastline at 0237, the pilots pushed their aircraft into a steep climb to 35,000 feet, well above the effective range of any surviving Houthi air defenses. The target area soon appeared on their displays as a thermal image captured by the aircraft's forward-looking infrared radar showed irregular geometric shapes that confirmed the presence of underground structures. As the formation continued toward the target area, the lead pilot designated 4 separate aim points across the control center's roof. In fractions of a second, the F-18's combat systems calculated the optimal impact angles that would cause maximum damage while keeping the aircraft as far away as possible. With 4 GBU-31 JDAMs on each aircraft, these F-18s had more than enough ordnance on board to destroy this complex, and several more if they wanted to. Finally, at 0242, the lead pilot gave the command, "All birds, release weapons. Time on target, 30 seconds." The bombs you see falling here are GBU-31 JDAMs. These are the bigger, better variants of America's premier air-to-ground precision weapon. This 2,000-pound bomb combines a standard BLU-109B penetrator warhead with a GPS guidance kit that makes it accurate to within 5 meters from any release altitude. However, this insane accuracy isn't the only thing that sets it apart. For this mission, technicians set the delay fuses to 15 milliseconds, giving the 1-inch thick forged steel case just enough time to penetrate 20 feet of reinforced concrete before detonating its 550-pound warhead, and they went off with full force. The first bomb impacted the primary control center entrance with pinpoint accuracy. A split second later, the Earth rumbled as the JDAM tore through 20 feet of soil and concrete. As it burrowed its way through the complex, it waited precisely 15 milliseconds before going off. In the immediate aftermath of each explosion, the bombs create an overpressure exceeding 5,000 psi. In confined spaces like this complex, any person within 30 meters would feel something that they're not getting back up from. And it only gets worse. To make this weapon even better, the strike used follow-through targeting, with bombs impacting the same entry points at 3-second intervals, drilling progressively deeper into the complex with each strike and increasing the bomb's overall effectiveness against hardened targets. Before the dust cleared, 7 more JDAMs struck across the complex. The strike was perfectly choreographed, with the first bombs targeting entrance points and ventilation shafts, while subsequent weapons hit the communication center and weapons storage. 8 separate explosions blanketed across the hillside, followed by a massive secondary detonation as stored munitions ignited. As the Super Hornets banked hard right and accelerated away, they left behind complete destruction. What had been a concealed underground facility was now a parking lot nearly 200 feet across. Real-time damage assessment showed the entire central section collapsed inward, with tunnel systems sealed by thousands of tons of debris. And this information was provided in real time to the pilots thanks to this aircraft. The E-2D Hawkeye, and it serves as the operation's eyes in the sky from 150 miles offshore. Its dome-shaped AN/APY-9 radar operates at 400 to 450 MHz frequencies that allow it to see through even the most advanced Houthi electronic countermeasures. And this big surface area also allows it to see huge swaths of territory. With optimal weather conditions, the radar can monitor a 6 million cubic mile volume of airspace, enough to cover all of western Yemen with a single aircraft. During the strike, its 5-person crew helped coordinate timing for all 16 JDAM impacts, ensuring they hit within 0.8 seconds of each other for maximum effect. And that's not the only thing that makes it exceptional. Its synthetic aperture radar penetrated the resulting dust cloud with 1-foot resolution imaging, confirming all 4 primary targets had been destroyed without the need for follow-up strikes. This real-time battle damage assessment capability means commanders know immediately whether objectives have been met, reducing the need to risk additional aircraft on unnecessary missions. But little did the Americans know there would have to be an unexpected second strike. At approximately 03:15, radar operators aboard the USS Carney detected multiple fast-moving contacts launching from positions near Al Hodeida on Yemen's western coast. 4 Iranian-supplied missiles were aimed directly at the carrier strike group. Within seconds, the destroyer's Aegis combat system calculated intercept solutions, and the ship's captain gave the order: weapons free, engage all inbound threats. 4 SM-2 missiles erupted skyward from the vertical launch system cells and screamed toward the targets. But this was just the first part of the engagement. I know you can't see it from here, but inside the ship is a supercomputer doing all the black magic that makes such a shootdown possible. The Aegis Command and Decision System is essentially a supercomputer designed for one purpose: shoot down threats before they can harm the fleet. While the ship's AN Spy-1 radar detected the incoming missiles at 267 nautical miles, 23% its official range, this data is useless unless it can be processed in a timely, accurate manner, which is where command and decision comes in. Over the next 1.8 seconds, the system processes over 4 million lines of code to generate a firing solution. Compared to before Aegis, this is at least 15 times faster than human operators could ever achieve. How it achieves this incredible speed and accuracy is through automated algorithms based on 28 separate parameters. And here is the really impressive part. All while this is going on, the Carney is simultaneously tracking around 127 other air contacts and working on potential fire control solutions in the background. Think of it as having 127 of the world's smartest mathematicians working simultaneously, while also solving one of the hardest math problems ever made in less time than it takes to say this sentence. But as great as C&D is, algorithms cannot reach out and touch the enemy. That is what these are for. These missiles screaming toward the targets are the RIM-66 Standard Missile 2, the Navy's primary air defense weapon. After launch, they accelerate to Mach 3.5 within 8 seconds. That's over 2,600 miles per hour, or covering a mile every 1.4 seconds. However, that's not all that makes them special. As these SM-2s enter their final few seconds of flight, each missile's active radar seeker kicks on. These seekers acquire targets with 98% reliability, even against threats with a radar cross-section of just 0.1 square meters, about the size of a bird. When the SM-2s close to within a few dozen meters of the target, their 140-pound warheads create expanding rings of metal fragments traveling at 8,000 feet per second. In total, all 4 of these threats were taken out long before they even had a chance to get a bead on the strike group. And soon, the US would move the Houthis to the find out stage of their villain arc. In retaliation for the latest missile attack, the US decided to send in a surgical strike without any fanfare to remind the Houthis who's boss. By 0330, a specialized 4-aircraft package launched from the carrier. What you're looking at is the F-35C Lightning II, which is the Navy's most advanced stealth fighter. Because the Houthis were now on full alert, the Navy wanted to keep the element of surprise by not sending up any Growlers again. That is why they sent a formation of 4 F-35s. They did this because the F-35 maintains a radar cross-section of 0.001 square meters, equivalent to a marble, that makes it virtually invisible on any Houthi radar. To further its stealth capabilities as it nears enemy positions, its primary air search radar, the AN/APG-81, operates in low probability of intercept mode that emits signals at just 2% of normal power. This decreases the already small chance of being detected to practically zero. And that's not the only thing that makes it stealthy. If you look here, you will see the F-35's electro-optical targeting system mounted under the nose of the aircraft, just in front of the main landing gear bay and beneath the fuselage. The electro-optical targeting system mounted under the nose detected heat signatures of recently fired Houthi launchers from 73 miles away, despite their camouflage. This feature, paired with the pilot's helmet-mounted display, which combines data from the aircraft's 360-degree sensors, allows the pilots to see through the aircraft in any direction. It's like having superhuman vision that can see in all directions simultaneously while identifying threats with near-perfect accuracy. But it's not like they even need it, thanks to the weapon they are carrying. Inside each F-35's internal weapons bay are the GBU-53B Stormbreaker, precision glide bombs that are changing how the US military conducts precision strikes. With a standoff range of 40 nautical miles when released at altitude, they allow aircraft to remain safely outside enemy air defenses. But while the standoff distance may not be the most impressive in the US arsenal, this seeker is what makes it truly special. The bomb's tri-mode seeker is here in its nose. This seeker houses a triple threat option of millimeter wave radar, infrared, and laser sensors. With this combination of sensors, no matter how dark, dusty, or sandy the environment is, this bomb will hit its mark no matter what. And these F-35s soon proved how good these new seekers really were. Upon making contact with the Houthi missile launchers, each bomb's 105-pound warhead created a strike radius of 26 feet, enough to destroy a launcher while minimizing collateral damage to any nearby civilian infrastructure. And if you thought that was cool, this part will blow your mind. During the strike, as the bombs were still in the air, the second wave of weapons received in-flight target updates as the first bombs detected launchers attempting to relocate. It's like having a smart bomb that can call its friends to tell them where the target is moving. By 0400, both strike packages had returned safely with no losses or aircraft damage. Post-strike analysis confirmed the control center had been completely neutralized, with an estimated 27 Houthi operators neutralized. The follow-up attack destroyed 4 of the remaining 6 mobile launch platforms, severely degrading their ability to threaten shipping. For the next 72 hours, not a single merchant vessel reported Houthi strikes, the longest peaceful period in the shipping lane since the conflict began. But will it last? The key question now was whether the April 16th strikes would push the Houthis toward a negotiated settlement, or if they would simply adapt their tactics while continuing to target one of the world's most vital maritime thoroughfares. But for a few hours that night, 4 Super Hornets and 2 F-35s demonstrated why they probably should negotiate. Bye for now.